Chapter 1, The Nature of Science. Lesson 3, Models in Science. It can be found on page 21. Today's lesson, we're going to, again, read through the section together so that you can follow along with this video and also be taking your notes for what would be on the back side of your note page, section 3. Let's get started. Our objectives for today's lesson: students will describe various types of models. Students will discuss limitations of models. Why are models necessary? Just as you can take many different paths in an investigation, you can test a hypothesis in many different ways. Miss Clark's class tested their hypothesis by building a model of the mystery box. A model is one way to test a hypothesis. In science, a model is any representation of an object or an event used as a tool for understanding the natural world. Models can help you visualize or picture in your mind something that is difficult to see or understand. Miss Clark's class made a model because they couldn't see the item inside the box. Models can be of things that are too small or way too big to see. They can also be of things that can't be seen because they don't exist anymore or they haven't been created yet. Models also can show events that occur too slowly or too quickly to see. Figure 18 shows different kinds of models. In the bottom left-hand corner, you have what would be a prototype. That means it's a piece of technology that has been developed, but it's not completely into development, so there's still testing that goes into it. You can see the cell model and the solar system model, things that are too big or too small to see, and then a dinosaur model, something that doesn't quite exist anymore. The example on this slide is of our model humans riding in a car for a crash test. We'd obviously want to use models in this case so that people aren't getting hurt in what would be exploring how safe a vehicle could possibly be. Now, how we use models in science: they represent something that is actually in the natural world and help us come to that understanding a little bit more of that item in the natural world. There are three basic types of models. Page 22, types of models. Most models fall into three basic types: physical models, computer models, and idea models. Depending on the reason that a model is needed, scientists can choose to use one or more than one type of model. Physical models. Models that you can see and touch are called physical models. Examples include such things as a tabletop solar system, a globe of the Earth, a replica of the inside of a cell, a gumdrop toothpick model of a chemical compound. Models show how parts relate to one another. They also can be used to show how things appear when they change position or how they react when an outside force acts on them. Anything that you can physically manipulate, touch, put your hands on, that's an example of a physical model. Computer model. Computer models are built using computer software. You can't touch them, but you can view them on the computer screen. Some computer models can model events that take a long time or take place too quickly to be seen. For example, a computer can model the movement of large plates in the earth and might help predict earthquakes. Computers also model motions and positions of that would take hours or days to calculate by hand or even using a calculator. They can also predict the effect of different systems or forces. Figure 19 shows how computer models are used by scientists to help predict the weather based on the motion of air currents in the atmosphere. Computer models, again, allow us to model using the computing power that can do mathematical calculations faster than you and I could even fathom. Allow us to run simulations on things on a repetitive basis so that you could do the test multiple times instead of actually having to do the test one thing at a time to find the results of an experiment. Our third type of models are idea models. Some models are ideas or concepts that describe how someone thinks about something in the natural world. Albert Einstein is famous for his theory of relativity, which involves the relationship between matter and energy. One of the most famous models Einstein used for this theory is the mathematical equation E equals mc squared. This explains that mass, m, can be changed into energy. Einstein's idea models never could be built as physical models because they're basically ideas. Making models. The process of making a model is something like a sketch artist at work, as shown in figure 20. The sketch artist attempts to draw a picture from the description given by someone. The more detailed the description is, the better the picture will be. Like a scientist who studies data from many sources, the sketch artist can make a sketch based on more than one person's observation. The final sketch isn't a photograph, but it is informative. Its information is accurate. The sketch could actually look realistic. Scientific models are made much the same way. The more information a scientist can gather, the more accurate the model will be. The process of constructing a model of King Tut, who lived more than 3,000 years ago, is shown on figure 21. If you turn the page, you can actually see how in the process from the basic skeleton, they would have assessed how the skin and the muscular tissue would have fit back onto that skull, and then by using clay, they apply to fill in those areas to give what the facial features would actually look like of someone who lived a long, long time ago. Pretty incredible. Bottom of page 23, using models. When you think of a model, you might think of a model airplane or a model of a building. Not all models are for scientific purposes. You use models and you might not realize it. Drawings, maps, recipes, globes are all examples of models. Models have several uses, and on page 25, we're going to identify those types of uses. Models communicate. Some models are used to communicate observation and ideas to other people. Often it is easier to communicate ideas that you have by making a model instead of writing your idea in words. This way others can visualize them. I don't know about you, but I'm a visual learner. I like to see things that are in front of me, and one way in which I can understand things, especially in science, is by seeing a model of what it is that I'm learning about. Secondly, models can test predictions. Some models are used to test predictions. In Mrs. Clark's class, they predicted that a box with a stapler in it would have characteristics similar to their mystery box. To test this prediction, the class made a model. That was the box itself if you read through the dialogue from the previous chapter. An automobile or an airplane engine use wind tunnels to test predictions on how air will interact with them. And those test dummies, again, are used instead of actually people to test how those things are going to result when a car crash actually does take place. Models can save time, money, and lives. Other models are used because working with testing model can be safer and less expensive than using a real thing. For example, the crash test dummies, shown in figure 22, they're used in place of people when testing the effect of an automobile crash. To help train astronauts in the conditions they will encounter in space, NASA has built a special airplane. This airplane flies in an arc that creates the condition of free fall for 20 to 25 seconds. Making several trips in the airplane is easier, safer, and less expensive than making a trip into space. This airplane is actually nicknamed the Vomit Comet. It goes straight up in the air, and people are kind of locked down to their seats, and then it dives straight back down to Earth, and inside of that, while the plane is falling towards Earth, there's a sense of weightlessness and gravity because you're falling inside of the plane. Therefore, the astronauts can simulate what it's like to be in space where there isn't any gravity. Page 26, the limitations of models. The solar system is way too large to be viewed all at once, so models are made to understand it. Many years ago, scientists thought that the Earth was the center of the universe and the sky was this blanket that covered the planet. Later, through observation, it was discovered that the objects you see in the sky are the sun, the moon, and the stars, maybe even other planets. This new model explained the solar system differently. Earth was still at the center, but everything else orbited, as was shown in figure 23. That was when we had the geocentric idea of the world. The Earth was the center of the universe. Models change, however. Still later, though, more observation, it was discovered that the sun, the heliocentric, the sun is the center of the solar system. Earth, along with the other planets, orbit the sun. In addition, it was discovered that the other planets also have moons that orbit them. A new model was developed to show this. Earlier models of the solar system were not meant to be misleading, and scientists made the best models they could with the information that they had. More importantly, their models gave future scientists information to build upon. Models are not necessarily perfect, but they provide a visual tool to help you and I learn. Now that you've finished your reading and or listening section for Science Today, you should have your notes taken care of. If you see here, this is section 3, Models in Science, in which you are filling in the blank for all the different parts of our reading. Those should match up, A, B, C, and D, the major sections that we talked about. Find those aspects from our reading and fill in the blank appropriately. Those notes in that reading will help you to take on your reinforcement, which is our assignment for today. Let's take a look at the instructions for that assignment. Top of the page, complete the following sentences using the correct terms. Numbers 1, 2, 3, 4, and 5 ask you to fill in the blank that is appropriate for each of the questions being asked. Numbers 6, 7, 8, 9, and 10 ask you to answer the following questions on the lines provided. So they are short answer, but they might take multiple sentences, again, using complete sentences to fully explain your understanding and your learning by answering the question here. Number 6 says, list one example of a model used to test prediction. What did we talk about in terms of testing something so that when you actually get to using it, you know that it's going to work? I don't know about you, but I don't want to ride in a vehicle that hasn't gone through some type of testing and safety process. And I don't want to jump on a plane unless I plan on jumping off that plane to see if it's going to be safe as well. So a lot of times things are tested ahead of time to make sure that when they need to be used, the safety precautions for different things, they're actually going to work. Maybe you could put that in your own words for number 6. 7 says, list one way a computer model could help a scientist study plants. I know you've been around for 13 or 14 years, but you may have come to the realization that things grow relatively slowly. If you've ever planted anything, you've done any gardening, you recognize that it takes a lot of patience in order to get those things to grow. Well, guess what? As a scientist, you don't necessarily have all the time in the world to find an answer to a question that you're trying to come to. So you want things to happen relatively rapidly, or maybe you could use some type of technology or computer program to see if that procedure that you're going to use, this growth that you're going to use in the botany or the planting, the study of plants world, could actually speed that process up. So the actually growing of something can take quite a bit of time. So you want that to be a lot more efficient if you're going to use some type of model to see if that's actually going to work out for you. Number 8 says, what are the limitations of models? I've got an example right here for you. This is a projection of our physical world. This is a map in which the world itself, that is spherical, that is round, it's not flat Earth. People say that they believe still in the flat Earth theory. It's not necessarily true. This round spherical object has been then projected and placed on and pushed onto this flat surface. Well, what that does is actually causes some of the distortions in what this actually looks like so that it's not 100% accurate. Remember, models aren't meant to be the realistic or the completely accurate way of depicting something. It's actually meant to represent something. Again, models are trying to represent things that are way too big, like the Earth, for us to see all at once, or something that's way too small and infinitesimal, like a small individual cell. Those are some of the limitations of models that you can probably summarize in your own words for number 8. Number 9 says, ancient scientists thought that the Earth was the center of the universe. Who remembers what's that called? Geocentricity. And imagine that the sky was this blanket that covered the planet. Why did that model change? Why did they once believe that the Earth was the center of everything and that there was this blanket that went over the top of it? Well, they probably thought pretty highly of themselves. And then they later realized that, whoa, there's this thing that we keep spinning around and it shows up day after day after day. And once we've come to this understanding of this bigger universe other than just the Earth itself, this solar system, there must be a reason why we're spinning around the largest object in that solar system. For we went from geocentricity to heliocentricity, this idea that the sun is the center of our solar system, center of our universe. Also kind of relates to what God said in His Word when He began to create the world. He said, let there be light. The very first thing that He made was, boom, right there in the center. And everything else around it is now uniquely and perfectly positioned for us to have life here on earth and for us to be right here in class learning about that world that our Lord created. How cool. Hopefully that helps you finish what is Section 3, your Models in Science. This goes back into your homework folder for Wednesday.